Given y of 0 equal 48, then solve dy ds equal 9.8 minus 0.196y. You were given the initial value problem. The high BP of 48 is given initially. Then you have to solve the differential equation. You can see the derivative and you have the function. So this is nothing but first order linear differential equation. Then to solve a differential equation whereby the high BP is given, so you need to solve for two solutions. The first solution must be the general solution. You pick it up from there and solve for the particular solution. To solve for the general solution, you need to apply the standard form of first order linear differential equation, which is dy over ds plus p of sy equal q of s. That is standard form. Then you have to rearrange this one into this format before you start solving. So let's rearrange now. From here now, dy dx is well arranged. Then you have this, you move it to the other side, you have plus 0.196y, then equal 9.8. So it's well arranged now. There you start solving now. So you can see everything is in this format. Your p of s is 0.196. The q of s is 9.8. The derivative is there. Then you have to get the integrating factor. Is extremely important. Get your integrating factor. So the formula for that one is exponential raised to power integral p of s. That is p of s ds. That is your formula. Exponential raised to power integral p of s ds. That is the formula for the integrating factor. Then the p of s is 0.196. You put it here, you integrate it, you now get the exponent. Will give us exponential raised to power integral 0.196. Then ds. That is what you have. 0.196 ds. You have 0.196 as a constant. So when you have 4 as a constant, if you integrate a constant, then you just put 4s. That is it. You have 10, if you integrate 10, is equal to 10s. So when you integrate a constant, you add s to it. A constant is a term without a variable. So when you have 20, the integral of 20 equal to 20s. So in that order, you can use the same concept here. So 0.196 is a constant. So when you integrate it, so you have it to be exponential raised to power 0.196s. That is your integrating factor. Exponential raised to power 0.196s is the integrating factor. So you have to use this to multiply the function, which is y, and use it to multiply the q of s. That's the 30s. So once you have the integrating factor, it is extremely useful. Use it to multiply y, just y alone. Then use it to multiply q of s. Equate the two of them. You have to equate the two of them. So let's go now from there. From there, so we have it to be y times integrating factor exponential raised to power 0.196x equal q of s, which is 9.8 times integrating factor exponential raised to power 0.196s. That is what you have. That is what you have. That is what you have. That is what you have now. You can see that is it. So the integrating factor is used to multiply y, which is the function. Then the q of s, which is 9.8, you also use the integrating factor to multiply it. This is the 30s. This is how you solve first order linear differential equation. Then you integrate the right hand side. Now you integrate the right hand side. That is the concept. You integrate the right hand side. So to integrate 9.8 exponential raised to power 0.196s. So you have this one now. To integrate this one, you need to use a u substitution. for this integration. Don't forget you are integrating them in terms of ds. That is it. It is in terms of ds. That is what you are trying to do. So you have to use a u substitution for this integration. So you let u equal 0.196 s. That is what u is. Then from here, du equal, at least you differentiate this one, is 0.196 ds. That is what it is. Then you make the s the subject of the formula. Don't forget, 1 minus 1 is 0. 1 minus 1 is 0. S for 0, that is 1. So you have 0.19s ds. So if you make the s the subject of the formula, you have the s equal du over 0.196. That is what you have. Then you put it here to neutralize the s completely. So now become integral 9.8 exponent u. Don't forget, everything here is u. So dot ds, which is du over 0.196. That is what it is. So you can see 9.8 over 0.196 there now. So when you put 9.8 over this, everybody here is one term. You can bring 9.8 over 0.196 separately. So will give us 9.8 over 0.196 integral exponential u du. That is what you have. So this over this is constant. So from there you can move on. From there so you have y exponential 0.196x equal 9.8 over 0.196 integral exponent u du. That is what you have. So this over this, let's integrate now. 9.8 over 0.196 equal 50. Then if you integrate exponential raised to power u, you also have e raised to power u. Take note, if you integrate e raised to power s, the answer is also e raised to power s. The integral of e raised to power s is also e raised to power s. And your s now is u. Look at your here now. So the integral of e raised to power u is also e raised to power u. So the u is gone, plus c, which is the constant. Then you now come back and put what you, don't forget your u. Your u is 0.196x. Then I have y exponential 0.196x equal 50 e raised to power 0.196x plus c. That is what you have, plus c. So don't forget that you are working towards y. So you want to get y of s. Therefore, you divide every term by e raised to power 0.196x. Divide everybody 1, 2, 3. There are 3 in number. Divide this by this exponent. You divide them 1 by 1. So with that, this will cancel this. You have y equal 50 exponent 0.196x over exponent 0.196x plus c over exponent 0.196x. So this and this cancel completely. So you now have your y equal 50 standing by. So plus, look at it now. There's 1 over e raised to power 0.196s there. So when you simplify the function here, you simplify completely. When you have 1 over 2, is 2 power minus 1. So the 1 over here will now become ce minus 0.196x. That is what we have. So you got it. So the general solution is available. So you have the general solution now. The general solution is done and dusted. So this is the general solution, which means that y of s equal 50 plus c exponent minus 0.196s. So the general solution is done and dusted. So we have to use this to get the particular solution. Why? Because we are given the IBP. Had it been you are not given the IBP, you stop here. This is your final bus stop. But when you have a question whereby the IBP is given to you, you have to use the general solution to get the particular solution. The particular solution simply means you're looking for C. The constant must be determined. So you use the IBP to get the constant. Now let's go now. The y of 0 equal 48 means that s, this is s now, s equal is 0. That is s equal is 0. But y of 0 altogether is 48. So y of s is 0, 48. 48 can take this place. Equal 50 plus c exponent minus 0.196s. X and s is equal is 0, then you put 0 there. That is it. So let's solve the problem now. So if s is 0, everybody here is condemned to be 0 because 0 times whatever you have here is 0. So you have e raised to power 0 there. That is it. Take note again. I repeat. If s is 0, everybody condemned here is 0. Everybody condemned to be 0 here. So s, 0 times whatever you have here is 0. So you have e raised to power 0 here. E raised to power 0 equal 1. 1 times c is also c. So you have 48 equal 50 plus what? Plus c. That is what you have there. So move your 50 to the rear. 48 minus 50 equals c. And c equal minus 2. That is what c is. C equal minus 2. So with that now you can now write the particular solution. So the particular solution is now y of s equal 50. Then c is minus 2 exponential minus 0.196s. That is it.